Okay, so I'm not exactly sure when the last video cut off, so I'm going to go back to the department store manager problem and make sure you understand that one. So again, you are taking 100 people out of 5,300 people who have a credit card with the store, and they're going to be called and read one of two advertisements. And then they're going to see if they use the credit card and whether or not the advertisement did its job in making them want to spend money at the store within 2 weeks of receiving that call. There are different methods that you can use with this. They can conveniently just call people. They can randomly just pick people. They can go through every third person and pick them. They could send something home and say, hey, call this number type thing, whatever. As long as you can justify it, you can describe the method. But remember that last sentence says provide enough detail so that someone else would be able to actually carry out your method. So if I read it, do I know what you're meaning? The second thing says the department store manager will flip a coin. If it lands on heads, they'll read it, advertisement A. If it lands on B, or tails, they'll do advertisement B. Why would he do this? A coin, unweighted, is completely equally likely. So the chance is that 50% of the people, so 50 people would get advertisement A and 50 people would get advertisement B. That is a theoretical probability. That's what's supposed to happen. Will it actually happen? Probably not, but it'll be really close. Next, a student wants to determine the most liked professor at her college. What type of study would be the most practical to obtain this information? A simulation does bring up randomness, so that is possible, but it would be very difficult to do at a college because there's thousands of people at your college. An experiment, if you're going to divide these into two groups and control something, I'm not exactly sure what you would control about an opinion about a professor. Observation, if you just kind of sit back and watch people, you're not exactly sure if they like the professor or not just based off their observations. A survey would be the most practical because you can send it out to people, they can answer it honestly, send it back to you, and it's just the most convenient as well. The last one is a margin of error type problem. It talks about Barnum's animal crackers that everybody's used to. It claims there are 2 servings per box, and a serving is about 8 crackers. So that says that there's about 16 crackers in that box. Is 16 accurate? Probably not, looking at our data. We have a dot plot here of an actual box of crackers. It says the graph displays the number of animal crackers found in a sample of 28 boxes. So this is 28 boxes, how many crackers were in each box. Use that data to estimate the average number of crackers in the box with a margin of error. Explain your reasoning and show your work. So first, you have to put all your information in your stat L1. Notice there's 1 box with 18, 1 box with 18.5, 5 boxes with 19, so that means you need 19 5 times, and so on. Once you run your statistics, so remember stat over 1 and hit enter, your average is 20, your standard deviation is 0.9, and then your margin of error, again, I did this problem wrong, so forgive me, would be 1.96 times 0.9 over the square root of 28. Let me redo this math. 1.96 times 0.9 divided by the square root of 28 is 0.33. So that means on average, the box 20 minus 0.33 is 19.67 to 20.33 from adding the 0.33. Cookies, when the actual level it says is 16 on average. So they're advertising that there's 16 in the box, when in reality of this sample space, there's 19.67 to 20.33 cookies. So they're actually underestimating it in this case. But the issue is, because there's only 28 boxes, that's why it's a little off. Whereas I'm sure Barnum's makes thousands and thousands and thousands, even millions of boxes of animal crackers. So that 16 number is based on that entirety.